Hello friends and welcome to your lectures on theory of automata and computation. Let us discuss today an example for method of conversion of NFA with epsilon to NFA without epsilon, or we can say that this method converts NFA with epsilon directly to a DFA, that is the deterministic finite automata. Fine. So to do this, what we need to do, we need to find out the epsilon closure of all the given states in the given automata, right? Suppose this one is the given automata. Now this one has 3 states. So what we'll do, we will find the epsilon closure of all the states and then formulate a transition table by using this epsilon closure. Please believe me, this method is very easy. Just have a look, right? So first of all, how to write an epsilon closure? To write an epsilon closure of a state, we first of all write the state itself. Fine, Q naught. Now we will go to the state Q naught and look if there is any epsilon transition from Q naught to another state. Fine. So we will look for Q naught. Q naught with epsilon is what? Q1. So we will add this to the epsilon closure set. Clear? Is there any other state from Q naught where we can reach by using epsilon? The answer is no. Fine. So this one set will include Q naught comma Q1. Now how to write the epsilon closure of Q1? First of all, we will write the state Q1. Fine. Then we will go to the state Q1 and look if there is any epsilon transition. No. Fine. So this set will include Q1 only. Next we go to the Q2 and look. First of all, we'll write the state itself Q2, and is there any other epsilon transition from Q2? The answer is no. Fine. So the set will include Q2 only, right? Now how to draw basically a DFA from the given transition diagram using this epsilon closure, right? So we will first of all draw a transition table. It will include the inputs. The set of inputs are 0 and 1. This table will give you delta, right? Over here, first of all, we write the initial state, that we all know, right? Now in the given diagram, the initial state is Q naught, right? But what we will do, we will not write Q naught here. We will write the epsilon closure of Q naught. What is that? This is Q naught comma Q1. Perfect. Now we will write the transitions of Q naught Q1 with 0 and Q naught Q1 with 1. Alright, let's see. Q naught with 0, Q naught with 0 is Q naught, right? Q1 with 0, no transition, so it comes out to be Q naught. But what we will write over here, we will not write Q naught, we will write the epsilon transition of Q naught. What is epsilon transition of Q naught? This is Q naught comma Q1. Fine, I hope it is clear to you. Let me repeat once again. What we'll do, for looking the transition from Q naught Q1 with 0, we will look first of all Q naught with 0. Q naught with 0 is coming out to be Q naught. Then we will look for Q1 with 0. Q1 with 0, no transition. So finally we'll ended up with finding the Q naught only, right? So over here we will not write Q naught. What we will write? We will write the epsilon closure of Q naught. What is that? Q naught comma Q1. That is why we have written over here Q naught comma Q1. Fine. Next, what we will do? We will write Q naught comma Q1 with 1. Fine. Now Q naught with 1 is Q2. Alright. And Q1 with 1, no transition. So what we come up with Q2. Now epsilon closure of Q2 is Q2 only. So what we'll write over here, we will write Q2. Now we will look at the next column state. Which is the next column state? This one, 0 and 1. These are the next columns, right? Next state columns. Now we will look for the any new state. Do we find any new state? If we look at Q naught Q1, transitions we have already written. So this is known as old state. Q2 have not appeared in this cell, in this particular column. So this one we will consider as a new state and write the transitions for Q2, right? Now we will look. Q2 with 0, no transition. Q2 with 1 is Q2 comma Q1. Fine. Q2 with 1 is going to Q2 and Q2 with 1 is going to Q1 as well. So what we'll do, we will look at epsilon closure of Q2 union epsilon closure of Q1. So epsilon closure of Q2 is Q2, epsilon closure of Q1 is Q1. So what it will come out to be? It will come out to be Q1 comma Q2. Fine. Now again, if we look, if we found any new state, what does new state over here means? That all those states occurring in these two columns but have not appeared in the present state column, in this column, right? Let me mark over here that this one is the present state and these are the next state columns. Fine. Now we will write the transitions for Q1 comma Q2. Now Q1, Q2 with 0, right? Q1 with 0, no transition. Q2 with 0, no transition. We will put a blank here. Then Q1, Q2 with 1. Q1 with 1, no transition. Q2 with 1, again 2 transitions. It goes to Q1 and Q2. See, Q2 with 1 goes towards Q1 and Q2 with 1 come back to Q2 also, right? So it comes out to be epsilon closure of Q1 union epsilon closure of Q2. What is epsilon closure of Q1? This is Q1 union. What is the epsilon closure of Q2? Over here it is Q2. Fine. So we will look that are we able to find any new state? No, because Q1, Q2 has already appeared in the present state column. Fine. So now to complete the transition table, we need to mark the final states as well. Now in this case, which one is the final state? Q1. Alright. So we will look in the present state column only. So which one is the present state column? This one, right? We will look at the present state column only and we look for, see, this one is the present state column, right? So in this column we look that which states have the final state as a set state, as a member state. So this one will become final state and this one will become final state. Fine. So this is our, you can say, converted DFA. If we want, we can rename these states and can rewrite the transition table as, fine, let's consider 0, 1, delta. Consider this as A, this as B and this as C. Fine. So what our transition table will become? A, B and C. Perfect. So A is the initial state, it is the final state as well. C is a final state. Fine. So with 0 it is coming out to be A, with 1 B, no transition, right? So this is C and this is C. What we done? We renamed Q0, Q1 as A, Q2 as B and Q1, Q2 as C. Fine. Perfect. So now this one is our corresponding DFA or a finite automata without epsilon closure, right? So now to draw the transition diagram, we'll use the transition with 0, with 1, it is going to be B, right? With 1, it is going to be C and then 1. Fine. So this is the corresponding DFA for the given example. I hope the method is clear to you. If you have any further doubts or queries, please mention in the comments below. We will definitely get back to you. Thank you for watching this video.